Hi, this is Serata from Clockwork Butterfly, and we're kicking off the second tutorial. I got one message asking me to start making the prototyping tutorials now, and 2 people asked me to continue with the production ones. This is Axel, say hello. So, we're going to continue with production. Today we're going to talk about silicone. And now, let's take a look at silicone first. It's a chemical compound, again, a synthetic one, that hardens into a fairly rigid rubber that allows you to make molds of it, so you can cast resin in them to reproduce your parts. This is the basic rundown. What does silicone look like? This is my jug of silicone. It's 5 kilograms one, obviously almost empty, and it's usually a white, very thick liquid. I have some here, which maybe you can see it flows just a little bit. It's really slow flowing, and my dog wants to give me a kiss for it. So yeah, it's very thick, very sticky, and this is an empty, again, bottle of catalyst, which is what you add silicone to thicken it, to set it, to make it set. This is a mold in the making. I didn't have enough catalyst. He really wants to eat it, so it's taking a long time. But here it is. And as for a finish mold, I have one right here. It's pink, as you can see, and it has 2 parts. We're going to talk about molds very soon, so be prepared. Now, again, as I said, and as you can see, there's one big jug and one tiny jug. While resin typically has more or less the same amount of the 2 compounds, with silicone you're typically going to have one huge jug and one tiny jug. There's silicone and the catalyst. Just so you know. It's really heavy. Sometimes it's sold by weight, sometimes it's sold by volume. If you happen to have it sold by weight, don't be fooled. It's really heavy. I mean, it may not look like much because this is kind of the same size as a 5 liter, aka 5 kilogram water bottle. But this was filled, I think, up to here. So yeah, it's significantly heavier than water, and just, you know, watch for it, because you may think you're ordering a lot and just get a tiny bit. A kilogram of silicone is, well, this is probably around 1.30 kg or so. It really feels heavy. Maybe it's 1.5. Either way, watch for it. And again, typically silicone itself, no dog, is white, and the catalyst is colored. We're going to talk about catalyst in a second. Now, with storage, it's the usual thing. You want to keep it dark, you want to keep it dry, airtight, and at room temperature. But silicone is not nearly as sensitive to that as resin is. I'm pretty sure it can even get wet, like literally wet. Darkness, as long as the container isn't clear. As you can see, it's still pretty see-through. I haven't had any problems, and I haven't had anything like with like I did with resin happen, where the catalyst would lose its strength and I would have to add more. I haven't had that happen with silicone. So basically, it's easier to deal with than resin. Now, additives. There are a lot, just like with resin, but they aren't used as often because basically you don't really want to mess with the finished properties of the finished product with the use of those additives. You usually affect the silicone before it sets. So you can extend or shorten the time. There are silicone dyes in case your catalyst is not already colored. So dyes are available. They're also useful if even if your catalyst is already colored, you may want to add a dye to part of the batch so you can tell the difference between them. It's not useful for ball jointed doll making, but for other uses it's pretty handy. Either way, you're not going to really care which color it is, right? You may need a different color to tell the difference between the batches of silicone, but typically you're not going to care about the color of the finished products because there's no difference what the mold's color is. The most often used additive for silicone is the thixotropic. It's a hard word for me, I'm sorry. Thixotropic additive. It makes the silicone thicker. It doesn't alter usually the setting time. It just raises the viscosity of silicone. And again, this is not something you're going to need for ball jointed dolls. This is for vertical glove molds. I will tell you what those are later, but basically you don't use them for ball jointed dolls. Now, storage using and etc. and tools you want to use with that. You want to buy big. Basically, first of all, as I said, it's heavy, so you want to make sure you have enough. And second of all, it doesn't go bad nearly as easily. I've had this particular jug for over a year. It's still pretty good, and it's not going to be so difficult to measure it once you learn when to stop pouring. It should be pretty easy, but with resin, because it's so thin and runny, you tilt it too much and off it goes. So yeah, definitely buy the biggest container available. I guarantee you're going to use that up even if your doll is tiny. Then for mixing, both the container and the mixing device, whatever you use, can be anything that is not porous. The reason why silicone is used for mold making is that the only thing silicone sticks to is more silicone. Anything else, it's not gonna stick. The difference is very porous materials like rough, unpolished wood, maybe some papers, something like that. Because then even though the silicone isn't sticking, it does get into every little hole, and it becomes almost impossible to remove. I have removed silicone from porous wood, so it is possible. But basically, as soon as it sets entirely, you don't want to mess with it when it's still wet. You can just pull it out and pull it off your stuff. I usually use this as my mixing cup. As you can see, no silicone inside, except for that stuff. Just pulls off, no problem. I use a wooden stick. I don't know, I found it somewhere in the house. I have no idea what it was made for originally, but it's more or less pencil shaped and sized. and it's fairly polished enough to for the silicone to not stick to it too much, and it does its job very well. And again, one more thing, Vaseline. Another thing silicone does not stick to is Vaseline. There are mold releases that are expensive, but you don't need them. Vaseline is all you need. It's dirt cheap and it does the job just as well. Now let's talk about catalysts. Usually, instead of, like with resin, you if you needed a different working setting time, you would buy a completely different resin. With silicone, usually you're going to have the same silicone and a few different catalysts available for it. For example, with this one, this is from ACC Silicones. They are, as far as I know, available all across Europe. I think they're not available in America. I have a choice between the red catalyst and the blue catalyst. The red catalyst is, I think the setting time is between 2 and 3 hours, and the working time, I don't remember, something like 15 minutes, half an hour. The blue one is 3-4 hours of working time, and the setting time is 24 hours. I would say typically for a ball jointed doll you want a faster catalyst. Slower ones are typically for like insanely complicated parts, or things where you need to add stuff to the silicone that will make it set faster, or uses in prop making, copying humans, stuff like that. Basically, not really ball jointed dolls, so you're going to probably look at faster catalysts. Now, one more thing I forgot about is the working and setting times. Sometimes the silicone is described just like resin is, in a working time and a setting time, where working time is while you can pour, and setting time is when you can take it out, basically. But more often you're gonna have 3 different times sometimes. There's working time, which is for pouring. There is demolding time, which is when you can pull your parts out. But I really need to find where that setting is that keeps cutting me out. Okay, even though you are able to pull out the parts, your silicone is not yet entirely as set as it could be. And at this point you really shouldn't use the mold yet. You should just put it back together and set it aside. And this time, the full curing time, as it is sometimes described, is usually between 24 hours and 2-3 days, depending on the catalyst, of course. So, the next point on the list is filling, aka reducing costs. Now, filler with silicone is not really gonna work. You want every bit of the original properties of the silicone to make a good mold, because otherwise it won't hold together as well, it won't flow over the pieces as well as it could, so you don't want to add anything to it. But there's one thing you can do. If you have old molds that you don't use anymore, you can cut them up into fairly tiny pieces and fill the parts of the mold box that are at least half an inch, I think, from the object you're copying. This way you can build up some of the volume, but the important parts of the mold are still going to be fresh silicone. So that's one way to do it. The old silicone becomes embedded in the new one as if it was always there. As I said, silicone does stick to silicone and does it very well. Now, as for safety, as always, refer to your seller and or manufacturer and try to stay on the safe side. However, silicone is not nearly as dangerous as resin is. You're going to be able to do it with gloves only or nothing at all, depending on whether you have an allergic reaction to silicone or not. It can irritate the skin even if you don't have an allergic reaction, so you know, better safe than sorry. Use gloves, but glasses or safety goggles, masks are usually not necessary depending on the silicone. So again, stay safe, guys. It doesn't even stink nearly at all, I suppose. If you're new to it, you're probably going to be more sensitive to the smell, but you know, resin reeks and this stuff hardly has a smell at all. Problems you may encounter while using silicone. If it's taking too long to set, make sure you measure the catalyst correctly. Just really, you're not going to be playing Einstein and switching the proportions around with silicone like you would with resin. Be careful, mix the proper amount. Also, if you're not satisfied with the setting time you've got, don't experiment, get a different catalyst. The catalyst itself is usually fairly cheap and you can almost always, I think in all companies I've heard of, you can buy it separately, so no problem there. If it's setting unevenly, some parts are setting faster, some parts are setting slower, mix it better. It's probably your error. And one more thing is always mix the catalyst before adding it. The dye is in there in order to help you mix it properly, because naturally the catalyst is going to be probably clear liquid in most cases, and the reason they add pigment to it is so that you can be sure that you mix it properly. Once the color is even, as you can see, you're not going to be able to see that anyway, but there's a thin streak of white here, which means that wasn't mixed well enough, while the other sides of the molds are all clearly the same even color, which means they were mixed well. If you just take the bottle of catalyst and pour it over, you're not going to get the dye in there because particles of the dye settle at the bottom. Now, it's empty anyway. You're not going to care so much about bubbles with the catalyst itself, so you can give it a good shake. Meanwhile, with resin, you're going to be super careful about turning it slowly. Catalyst, just shake it. Once it's an even color throughout, you can use it. If it ends up bubbly or not reaching every part of the mold, either the mold is badly engineered or you're not pouring it in a right way, and I will teach you that because that's a longer subject. But basically, if you're doing everything well, the silicone will get everywhere it should. No questions about that, it just will. If parts of the mold are not separating properly, like I showed you there where they would, then you didn't coat them with mold release, aka Vaseline, neatly enough. Get a brush, get in there. You can cut the mold up and use it even if the parts did fuse together. We just gotta cut it up carefully and everything will be alright. Basically, don't sweat. Even if you just mess everything up, as long as the part is roughly in the middle and surrounded by silicone, you can salvage it. I will teach you how, just don't panic. Now, what to look at while buying silicone? First of all, its working times. As I said, you may encounter 2 different time values or 3 different time values, depending on how your manufacturer chooses to refer to them. Basically, you want to know how long you need to wait before demolding, aka removing the parts from the mold, and how long you need to wait before using the mold. You want to be careful about density. Again, if your manufacturer sells by weight, you really need to measure that carefully, or you will end up not having enough. Having too much is also kind of a problem because silicone is expensive as hell. It's not exactly more expensive than resin, although it depends on silicone, but you're going to use a lot of silicone. I mean, this is the mold. This is the part. See the difference? This is about 80 grams of resin. This is almost 1.5 kilos of silicone. So, you know, you're going to spend a small fortune on silicone just because you need so much of it. So it ends up adding up, and it ends up being a huge investment. You need to pay attention to the strength of the silicone, which will tell you how many uses of the mold you have. Typically, out of a mold you get, depending on the silicone, between 20 and 100 copies. It all depends on how soft the silicone is. Now, here's the thing to have in mind. Silicone can have different strengths and different resistance to tears, because it kind of tears like fabric. Now, the softer the silicone is, the easier it is to tear, but at the same time it makes the molding process easier because it's squishy, so you don't have to be so precise with your molds, because you're going to be able to demold it anyway. Just push it, squeeze it, and off it goes. But it's a lot less durable. If you pick a silicone that is thicker, it's going to be more resistant, it's going to be able to be used more times, but you have to be more careful with how you construct your molds, because there's not as much place for cheating. Mine is around the middle, but definitely closer to the thick, solid side of the spectrum. So it can be bent, but squeezing it is just not really gonna happen. So yeah, this is it. You want to know what proportions you need between your catalyst and silicone, and you also want to make sure that you're getting enough catalyst. Typically you're going to get exactly as much as you need assuming you were a machine and did everything absolutely perfectly, and you're not going to do that. Because catalyst is runny and because you use so little of it, you're probably going to end up pouring too much, so get some extra. And last thing, some silicones may require a vacuum chamber to degas and to set in, so avoid those. So yeah, this is it. Give me your questions, give me any problems you might have understanding this tutorial, or any other comments. You're hearing my dog licking his butt probably. And yeah, check out my Patreon page, check out my other videos, the list of upcoming tutorials and other stuff like this. Thank you. Bye.